All right, number 15. What does it say? Which of the following integrals gives the area of the region that's bounded by the graphs of the polar equations? Okay, so they're not expecting you to actually know what this looks like. I do not know what this looks like. So that's good because all they want is that you know the formula, right? So the area and polar, remember, the formula is 1/2 r squared d theta from theta 1 to theta 2, right? So r squared is this, so this should be squared. So which one of these, just look at the choices and see which one has them squared, right? This is not squared. This is not squared. The last, oh, this is really square down here. I don't know what's happening over there, but it's got to be one of these three. Okay, so then this would become 1/2 0 to pi over 4. That doesn't matter. The limits don't matter because they're all the same for all the choices, so that's not going to change anything. And then when you square that, you get 4 over cos theta plus sine theta squared d theta. All right, and the half and the 4 cancel out. That's why none of the choices have a half. So it's choice C. Cancels this. Excuse me. Okay. Moving on. 16. Oops. 16. What do we have here? Oh. So just notice that this is nothing. So this is testing your Maclaurin series memorization. This is just the e to the x series, but x has been replaced with 2. So this is, the sum is e squared. So it's choice B. There's no math, just know your formulas. Okay. If you write this in Cartesian, finding the second derivative would be a lot easier. So here's what I mean. We know that x minus, if I solved, okay, I could solve for t squared from here. Okay, so x minus 4 equals t squared, right? Then I can put that in here. So y equals x minus 4, that's t squared, but this is t to the 4th, so I have to square it. So y prime is 2x minus 4, and y double prime is 2, and I am so done. Okay, so once again, what we did, if ever you can do this, rewrite, if they ask you for the second derivative parametric, you know how messy that could get, so just rewrite the function in Cartesian form, or rectangular form, however you want to call it, right? Solve for y in terms of x, and then take the derivative that way. Okay. Yep. So that's that. 17 is choice B. 18. Okay, this looks like an antiderivative. Okay, so let's take the antiderivative. They want the original function, so. Okay. So what do we have? We have, if I take the antiderivative of that, I would get negative 10 e to the negative t over 2 divided by negative 1/2, right? If I were to take the derivative, I'd multiply by negative 1/2, but I'm taking the antiderivative, so you do the opposite. Plus c, really. And I'm just simplifying this a little bit. Dividing by negative 1/2 is the same as multiplying by negative 2. So this is 20 e to the negative t over 2 plus c. And we know that when x is 0, y is 20. So we'll just plug that in. Y is 20 when t is 0. So c is 0. We don't even really have to look at that because that's the only choice. None of the choices have a c. So 20 e to the negative t over 2 has to be it. Now we plug in 6 there. So that becomes 20 e to the negative 3. Okay, which is B. Okay, this was pretty straightforward if you know your antiderivatives. Oh, interesting, number 19. Okay. Let's be the function, the coefficient of x cubed in a Taylor series for f. Okay, so let's remember Taylor series, the coefficient of x cubed, the Taylor series of f. This is really the Maclaurin because it's about x equal to 0. So you have x cubed, the third derivative at 0 divided by 3 factorial. That's the third. That's what the third term of Taylor's looks like. So they want this. Okay. So they gave you the second derivative. If you take the derivative of that, you find the third derivative. So f triple prime is 3 over 2, 1 plus 3x. Remember, I'm invoking the shortcut here. The derivative of this is f prime over 2 squared of f. Okay. And when x is 0, I'm just getting 3 over x is 0, so I'm getting 3 over 2. Does that work? Okay. So that's just f triple prime at 0, though. Okay, at x equal to 0, that's it. So that's just this part. Now I have to divide that by 3 factorial, which is 6. So 3 over 2 divided by 6 is the same as this, and I get 1/4, which is choice C. And that's that. Okay. Number 20. What is the radius of convergence? Okay, so I'm thinking ratio test for absolute convergence. So limit as n approaches infinity, absolute value a sub n plus 1. I think that said 2. Divided by a sub n, which means multiplying it by the reciprocal. Okay, and let's be careful. Here we want this to be less than 1, remember? Let's see what we get. So this cancels with that, so we get x minus 4. 2's cancel out, and we have 1, 3 in the denominator. Okay, so the answer is x minus 4 over 3. It has to be less than 1 to converge. So if you solve for x, minus 4 has to be between, multiply by 3, right? It's negative 3 and 3. And so your radius of convergence is 3. If you add 4, it doesn't change the radius of convergence. I'm sorry, plus 3, plus 4 here. This is positive 1. Okay. So half of this interval, so this is 6 units. Half of this is 3. Okay, and that would be choice C. 21. Okay. There we go. A p-series. They both diverge. Okay. Well, if it's x squared, it's not really p-series, it's the integral. I'm looking for the easiest one, which I think is 1. Because if p is 1, then I get 1 over x here, and that's ln. The antiderivative, that would be ln. And when you substitute infinity, that's not going to converge. And same thing here. When you substitute 0 into ln, it's not going to converge. So it'd have to be that. Yeah. That's it.